Okay. Welcome all to this webinar, live webinar on cloud computing and DevOps, co-hosted and presented by DY Patil Pratishthan's, which namely has two institutes located in Akurdi. One is DY Patil Institute of Management Studies, which is a premier MBA institute under Savitribai Phule, Pune University, providing specializations in marketing, HR, finance, analytics, operations, etc. And it has been and along with that, we have got a technology training center, advanced technology training center as well, Institute for Advanced Computing and Software Development, which caters to the high-end technological training, which prepares the students for their career into the IT industry. So something about DY Patil Institute of Management Studies. It was established in the year 2014, and it has been a 16 years long journey. Of late, our students have been placed in good organizations and started big in their career, and they have started as an entrepreneur. Some of them have become entrepreneurs also, because we have an entrepreneur development cell. Also, along with the normal MBA training, we also have got research center, and some of the PhD scholars are undergoing the work on the PhD thesis, and many multiple students have already been awarded PhD through our institute. So that was short brief about the DY Patil Institute of Management Studies. We also, by the way, myself, I am Professor Keshav, working in the capacity of assistant professor at DYPIMS, and also as a career advisor to the IACSD. I am there as career advisor to IACSD. Something about the Institute for Advanced Computing and Software Development. So it was established way back 20 years back. That was established in the year of 1998. And it has been a long journey since then, 20 plus years of existence. And we, at the moment, currently, we have diploma courses which specialize in the advanced computing, big data analytics, and the IT infra and system security. We also have got a diploma course for advanced software development methodology. We also run a preparatory course called PREDAC, which prepares the students to, get admitted into the CDAC various courses. CDAC is a post-graduation diploma course, 6 months, which prepares students to launch their career into IT industry. This was, our IACSD was, outcome of the visionary mission of Dr. D.Y. Patil, Dr. D.Y. Patil, founder and president of Dr. D.Y. Patil Pratishthan. And the institute has been engaged in providing a, launch pad to the aspiring engineers in the field of IT. And as I told you earlier, it was established way back in 1998. This institute has been nurturing and developing skilled manpower in the field of IT and electronics. To add to it, probably our students have reached great heights. They have reached architect level. Some of them have become entrepreneurs and they have started their own organization, because the training what we provide is excellent and which propels their career in the IT industry. Also, I'd like to welcome, this was a brief background about the DYPMS and IACSD. I'd like to welcome Mr. Vinu. Mr. Vinu is the co-founded a startup called Karik and has successfully exited last year. He is a big advocate of open source, and he has over 20 years of experience in IT, of which he has spent 7 years in Red Hat. He is one of the resource person for today's session. Good morning and welcome, Mr. Vinu.
Good morning, Keshav. Thank you.
Yeah, and let me just give a short brief of Mr. Sagar also. He is the resource person for today, along with Mr. Vinu, who is also the resource person. He has got close to 20 years of experience in IT industry, working in cloud, big data, and IoT domain. And running DevOps company Glisten Software since more than 6 years. And he has worked more than 8 years in a company called Persistent, which is well known to all the technology enthusiasts and those who are, those who are in with the IT industry. Everyone knows how big is Persistent company. So with this, I complete the short briefing about the institutes and the resource persons. And welcome, Mr. Sagar. Good morning and welcome, Mr. Sagar.
Hey, thanks, Keshav. Good morning, everyone.
So over to you, Mr. Vinu. Please carry on. It is an honor and pleasure to have both of you as a resource person, and along with them, our alumni Shivam is also there. Welcome, Shivam.
Thank you, sir. Good morning, everyone.
Okay. So over to you, Mr. Vinu. All yours, please.
Yeah. Hey, everyone. Good morning. I hope everyone's fine. The pandemic's not stressing you all out. I know it can be tough sitting at home and managing all these things. So yeah, as Keshav said earlier, this is the new normal. You'll get used to sitting from home and working from home, having your classes online. You don't know how long this is going to last. So yep. So along with me, I'm going to have Sagar, and we're going to be talking about two different topics today. One is about cloud computing, and the second topic is about DevOps. So what we're basically going to do is focus on cloud computing and DevOps from a career perspective. This is not a technology presentation where I'm going to make you aware of teach you a technology. I'm not going to do that. What I'm going to tell you is these are the various things which are around in cloud computing and DevOps. Probably you could be interested in looking at these skill sets if you're looking at a career in either cloud or DevOps, cloud and DevOps. So that's the approach which I'm going to take. And what I'd appreciate is I'd like to keep this interactive. So we're going to keep the chat channel open, right? And I would appreciate it if you guys could kind of respond on the chat channel. Yep. And Sagar, can you do me a favor? Can you monitor the chat channel while I do the presentation? And I'll
Yeah.
the chat when you talk.
Sure. Yeah, sure. No problem.
Right? Okay, great. So guys, I suppose you all can already see my screen, right? Someone confirm, Sagar.
Yeah, I can see your screen. I think some people are saying that they are feeling the echo actually.
They are?
So yeah, so I think I would request everyone else to stay on mute except for Vinu, so that we don't hear echo for others.
Okay.
Yes, I think you can go on.
Right. Right. So the first presentation is going to be on cloud computing, right? Cloud is a very ubiquitous term. It's very common. People use it. I'm sure everyone among you is also aware of it. But various people have, different understanding about what cloud computing is. So, one second. Can someone, probably just type out what is their understanding of cloud computing? A brief one-line this. Listen, guys, I know everyone's online. You have access to Google. I'm absolutely fine with anyone searching for information and pasting it over here, because I know the ground reality is even after you finish your course and your experience, there's always something you don't know. And even in a career, you're going to end up searching on Google. As long as you're smart enough to search and find the relevant information, great. I have no objections to searching. So I'll give you all about a minute. Can you guys kind of just quickly post what is your understanding of cloud computing?
Okay, so we know you have two, three answers. Cloud computing is a domain for rendering of exact service,
Okay,
different services through the internet
right,
using massive pool of resources according to our requirements. Different types of services are provided through internet.
correct.
Yeah, so I think most of them are around resource provisioning, I believe.
Perfect, perfect. So yes, in that sense, you guys are on target, right? So I'll just distill cloud computing to its most basic definition, which is written right on top. It is basically on-demand availability of computing power and storage, right? That's all. Now, how did this come to evolve is a interesting bit of history. Awareness is always good to have, right? So if you look at the, what do you call, data centers and organizations prior to cloud computing, right? What would happen is they would have dedicated a set of resources available, right? And you would deploy your application onto it. In case you wanted additional resources, what would happen is you kind of raise a purchase request. You know, the guys go out, buy the hardware. The IT department will provision the server. The software guys, I mean, the operations guys will deploy the software on it. You know, and finally it will get operational. This process, depending on the organization, could be anything between 2 days to, like, you know, months at a stretch, right? So now what happened is in this method, it's kind of inefficient. Forget about the time. The hardware resource being dedicated for a specific use is kind of inefficient. What happened is a technology developed which is known as hardware virtualization. What basically happened with hardware virtualization is that now you could virtualize another instance of an operating system inside the hypervisor. So you could have multiple VMs running inside a host, and each VM could perform a specific task, right? So in case there was capacity underutilization, now you had the ability to utilize the capacity properly by provisioning another VM on it, right? Along with it, the software architecture changed around that time. Things developed into something known as a a service-oriented architecture. What is a service-oriented architecture? Uh, Basically, what happens is that you have different components of an application. Some components request for information, some components provide the information. Now, this communication is very often standardized, and it's what do you say? It happens across the network. So you could have things distributed across multiple compute resources, right? And somewhere around the same time, the concept of autonomic computing came up. What is autonomic computing? We are talking about self-healing systems, you know, systems which get aware of the fact that, you know, probably this VM is not working, this service is not responding. Let's fix it, you know. So fix it is probably spin up another instance, kill this instance, right? Or probably something like a network route being down. So you decide, let's not take this path, let's take a different path. Now, these things all came up, and when they combined together, it came up with interesting possibility. So you have a concept of utility computing. It derives itself from, what do you say, how utilities are provided to us as end users. What do you mean by utilities? We are talking about, let's say, electricity, water supply, right? Now, let's compare it and figure out what the difference is. So if I'm in a traditional data center for an organization, right? What do? I go ahead and buy a server, right? And I use it. Buying a server is something known as a capital expenditure, CapEx, right? Whereas what happens with utilities? Do I buy a power plant? No, I don't. I utilize electricity and I pay only for the units I use, right? I don't pay as a capital expenditure. It's just an operational expense for me. It's a recurring operational expense, right? So someone decided, hey, let's introduce the concept of utility this into computing. So what you have is something pay as you go, right? So all these things combined together and led to something known as cloud computing. So what does cloud computing eventually provide you with? It basically is a combination of features what you see on the left hand side. It's like better use of resources through multi-tenancy. It's a highly scalable and elastic, infrastructure. Uh, it's infrastructure which can be quickly deployed or destroyed. You know, it's very resilient, reliable, highly available, and it has a set of tools to allow you to easily manage it, right? So this is like a combined this what defines cloud computing. We talked about multi-tenancy and what do you call
Hey,
it?
Sorry to interrupt you. Can you go back to the previous slide? Just, I would like to highlight a little more on CapEx versus OpEx. Okay, so just what exactly it means. Okay. Uh, One important concept is basically you might not require a resource for the entire duration. For example, currently you might have seen that okay, few of the organizations have become hit suddenly. Okay, and they become so popular that there are millions of users or thousands of users who try to visit it, and then after a couple of days the popularity is becoming a normal kind of thing, and then there is not enough demand for that product or requirement. Okay, and when there is a popularity, usually you need more infrastructure. Okay, so there actually you need to allocate more and more resources to the infrastructure, and then once the demand goes, so a good example would be, or analogy would be, I think everyone might have done IRCTC booking. Okay, and Tatkal booking is quite common. Okay, at 10 a.m. The servers become virtually unresponsive. You might have failed to do a train booking. Okay, and at 10:10 you might be able to get enter into the booking area, but you might there are no seats left. Okay, so for that given 10-minute duration, there is a lot of compute capacity that would be required to serve the request, because there are millions of users trying to make a hit for the train booking that you are looking for. And after a couple of minutes, there might not be a required. So in such a situation, if you look at are you going to allocate by say to serve those requests, actually millions of requests, you might require say 100 physical servers. Okay, so are you going to purchase the 100 physical servers for the duration of 10 minutes that you want to do? Probably not, because after those 10 minutes, you might feel that, okay, I don't need those 100 servers. Okay, so what you will do in such a situation? For that spike of data that you need, you don't need to enter into that procurement process, okay, and buying the servers of the hardware which you don't need. So the compute power, you need it only for a specific duration, and that is where the capex versus opex come into thing. Okay, so instead of buying physical servers and reserving it for that 10-minute duration, and after those 10 minutes are over, you might not need those servers for anything else. Okay, so rather than doing that investment, I would rather buy it from a cloud environment for those 10 minutes, and after those 10 minutes are over, I can release that infrastructure back to the open pool. Okay, so that is where the capex, that okay, whenever there is a demand, you can get the infrastructure, and when there is no demand, you can release it back to the open pool for other people to use it. Okay, so that is where the operational cost. So when you are paying for the services, you will be paying only for those a 10 minutes of duration, the pay as you go that Vinu mentioned. Okay, so it is important to understand that what benefit you are getting from cloud computing. There might be other industries where they feel that, okay, I want to do some evaluations for a product, and for which they might purchase a new server. Okay, but the test might fail and the idea might not work out. So then they will say that, okay, I don't need the infrastructure anymore. And ideally, the investment that you have done for the infrastructure might go in vain. Okay, so in such situations, if they go to cloud computing, okay, if the idea doesn't click, they can release the infrastructure back to the open pool, and they don't have to pay for the infrastructure throughout the life cycle. Yeah, Vinu, you can go on.
So, okay, this is a visual representation of what Sagar was just talking about, right? You see a sine wave type black line, right? That is basically the demand. You see it go up and come down over a period of time, which is along the x-axis, and the y-axis shows the compute resources required, right? And you see a green horizontal line, that is your available capacity. That's basically the amount of compute power that you have. So you incur a capital expenditure to buy, let's say, as Sagar said, 50 servers or 100 servers, you have done that. And an example which Sagar gave you was IRCTC, which at 10 o'clock in the morning starts with Tatkal. That's when there is a spike and you see the sine wave going above the green line and reaching the red line, the red dotted line on top, which is the required capacity to be fully functional at that point, right? Another example is like what happened in my previous startup. CarIQ basically had a device which sent data from the car to our servers, right? Now, when is a car used typically? Most people use it for commute to work and back home. So you would see a spike in usage between 8 o'clock in the morning to say like 9 o'clock or 10 o'clock, and in the evening at about whatever 5 o'clock to 7 o'clock, 8 o'clock. The rest of the day, the car is just idly parked somewhere. A few people are traveling. That's about it. But the bulk of the traffic and bulk of the data comes between these two slots, right? And middle of the night, there is absolutely no traffic or whatever. That's how it works. So what do I do to handle the search? As Sagar said, if I install, okay, before I go into installing additional hardware, the implications are defined over here in the sense you see the top curves, right? The peaks and the red blobs within it. That's basically a revenue loss for you. Because if you can't cater to the people who are trying to access your service during the peak hours, you're basically losing a customer, right? So in my case, it could be like in CarIQ's case, it's like people say that during the peak hours, my data never reaches the server, so my data is never visible to me. So why should I use your service? And I'll stop using your service. So ideally, I need to have a mechanism which will say like, hey, let's figure out a way where we can take in the data during the peak hours also. Now, the reverse is also true. What happens during the non-peak hours? During the non-peak hours is you see all the valleys, which are the ones below the green line. There is absolutely no utilization of the compute resources at that point. Like at 1 o'clock in the night, barely any cars are running around. I don't want 50 servers to be up and running at that point. In IRCT's case, like after 8 o'clock, reservations are not happening, right? What do you do in that case? Or 11 o'clock, I'm sorry, I don't know the time, but after a certain time, reservations are shut. So you don't need the servers at that time. But if the servers are up, I need to still bear a cost for it, right? An operational cost for it, the running cost of it, I still have to bear it. So, okay, fine. I don't want to lose customers. So I say like, let's buy another 50 servers to increase the capacity. So now suddenly from the green line, my available capacity becomes the red dotted line. Great. But that means the unnecessary overhead has become that much more, so it's very inefficient. So what cloud computing does is it manages to synchronize both of them. Basically what it does is it uses something known as dynamic provisioning. So you see that the capacity and demand, both of them kind of run parallel to each other or they overlap each other. So in car IQ's case, what I say is like, hey, as the number of cars increase on the road and they start sending data, let's spin up some few more servers so that they can accept the data and process it. And after 10 o'clock, as the number of cars on the road start going down, let's reduce the number of servers and probably keep it down to a minimum of 1 in the middle of the night, you know, for the odd car which is traveling and sending data. But I don't need any additional servers at that point. And next day morning, the same thing happens. You know, I need to increase the number of servers to handle what you call the increase in number of cars sending data. Another example of this would be something like when an e-commerce company decides to start off a sale, like Flipkart's coming up with a sale, you know, in the next few days. The number of people who are going to be shopping at that time is insanely huge, right? But does it make sense for Flipkart to have a dedicated compute resource throughout the year for that, when the sale is just going to last for 3 days and probably they run like 20 different sales in a month? You know, and let's assume each sale lasts for 3 days, 20 times a month. It's like 60 days. You're saying that, you know, let's keep all the resources up for 365 days when for 300 days there is no rush at all. It just does not make sense. This is where cloud and dynamic provisioning kind of kicks in. Okay. Just to go back, we talked about virtualization earlier, right? So this kind of explains how virtualization and multi-tenancy kind of help you optimally use your hardware resources. Let's say you have a company with 2 different departments. Each department procures its own hardware. Department red, which is on the extreme left, has its server. It deploys VMs onto it. They're happily using it. Department green has another server. They have their VMs on it. You see the amount of empty space in between the 2 servers, right? I theoretically can run another 7 machines. Sorry, not 7, 5 machines over here. That's wasted resources. So the company says, hey, let's switch over to something known as multi-tenancy, where the departments can use the shared hardware, right? So now the 2 VMs of department red and the 1 VM of department green are running on the same, what do you call, host, right? So it's optimal usage. So now I don't need 2 servers. I just need 1 server. That's how it works. Okay. We've already been through this and this.
So Vidu, I think you have your first question from Naval Bansal. By switching off unnecessary services for a particular time, can we achieve dynamic provisioning?
Yes, right.
Yes.
What do you mean by switch off, right? I mean, are you talking of pause? Are you talking of destroying it? It depends.
Right. Right. So I think what he meant was basically you switch off the servers when not required. Okay. So I think it is a kind of dynamic provisioning only. But from a capex versus opex perspective, I think you have saved on the power cost to run the servers, but still you have invested significantly on procuring the servers. Okay, so partially it will help, but it will not be a significant means. Power you might be able to do it because power you are getting it in opex mode only. Okay, so when you don't need the power, you switch off the servers and you will be saving on the power. But the capex cost will still be there because I think you might be spending means a good server that you are using for the infrastructure might cost you around at least 4 to 5 lakh rupees per server. Okay, and when we are talking about 50 or 60 servers, you are talking investment more than CR crore, more than 2-3 crores. Okay, and in that case, you are not saving a lot on the cost, because the power wise, if you take an annual costing for power saving, it might be in thousands or lakhs of rupees, but you have already spent crores of rupees to procure that hardware. Right. So the saving would not be a significant saving when we take a large scale enterprise kind of organization where they are trying to capitalize on the capex versus opex.
Right. So I'll just add to what Sagar said. In one way, what you asked could be absolutely true in the sense that I have an unwanted VM running. I can power off the VM. And in that place, there is another application or service which needs extra compute resources. So I can spin up an additional VM for that application and run it on the same hardware. So I am using my resources more efficiently. Perfect. Great. But the other side is what Sagar just mentioned. You know, we're talking about the physical hardware, right? The physical hardware, if it's running, you're still consuming power. Your AC requirement is going to go up because the machines heat up. So more machines are on, more heat, more air conditioning required, and things like that, right? So in that case, as Sagar said, you'll probably power off the machine. Then I have a question for you. If you physically power off a machine, how do you do it at a scalable model where, let's say, you are powered off 400 machines, now you have to power on 400 machines? It kind of becomes difficult, right? So this is where cloud computing comes in because manageability is another feature of cloud computing, as we saw earlier, right? It makes it easy to do the things for you. Look, what it basically does is you as an end user have ease of use. The headache is taken on by the cloud service provider, be it Amazon, be it Azure, be it Google. They take the headache. You know, if they have to figure out how to power on an extra physical machine because there is a search required, it's not your headache. They figure it out. You just say that it's easy for you to say that I want to spin up a new VM. That's it. If there is no underlying physical compute available for it, Google figures out that, hey, I need to get more machines into the system. They typically have additional capacity and whatever. It is their optimization, it's their cost saving, it's their headache. It's no longer your headache, right? So there are multiple, models within cloud computing. Typically, most cloud service providers will provide all three, right? Have you all heard of infrastructure as a service, platform as a service, software as a service? Could anyone describe what infrastructure as a service is, what platform as a service is, what a SaaS model is? Sagar, you're mute, I think.
Yeah, I think 2, 3 people replied yes. Few of them said they don't have any knowledge, so maybe you can just describe it for everyone.
Okay, fine. Right. So infrastructure as a service is basically giving you a virtual infrastructure. It's very raw. What it does is it gives you a VM, it gives you storage, it gives you a network, it gives you a load balancer. You have to do the heavy lifting. Let's say you have a VM, you want to run Linux on it. You decide I want to run Ubuntu, I want to run Red Hat Enterprise Linux. You install it, a particular version, a particular update. You do that, right? You decide I want so much storage. You request that much storage. You attach it to the VM, right? If let's say I have 2 VMs, I need to load balance traffic between the VMs. So I define a load balancer, connect both the VMs to the load balancer. Then I go ahead and kind of deploy my application onto the VM. I go ahead and configure another set of VMs for the database server, right? I go through this whole process. I do all the heavy lifting, but it offers you phenomenal flexibility, right? When you go to platform as a service, what the cloud service provider does is they abstract away a huge part of the infrastructure from you, and they say, I am offering you a database platform or a web server as a platform. That's all they're doing, right? So you say, I want a MySQL database. You don't care how AWS, Azure, or Google is managing the database, right? All you get is what do you call a ODBC connection string. You put that in your application, you connect to the database, you use the database. That's all that happens. Same way, you have a web server or an application server pre-configured running Tomcat. They're running it as a service. You deploy a jar file into it, WAR file into it, and you're done. That's platform as a service. Then the cloud guys decided, hey, we can make life much more easier for you, right? Why don't I offer a complete service to you, And they started calling it software as a service. A classic example of software as a service is like what we are doing right now, Zoom. I'm just utilizing Zoom servers and services to conduct this session. Companies, what do? Instead of running their own mail servers like Outlook, Exchange, and whatever, they said like, hey, let's not do it, Let's just go ahead and pay 100 rupees, 150 rupees per user, and we can host all our emails on Gmail or let's say Office 365. CRM, let's just use Salesforce. So it's a pre-configured thing which is running. They manage it. You customize it as per your requirement. What do you mean by customize? Email, I create the user ID and I say like, give him access to these apps. Don't give access to these apps. I set the policies and I use it. But what is lying underneath it, it's not my headache. Google takes care of it. Microsoft takes care of it. And it is completely transparent to the client, which is you, the end user, right? How do you access email? You could have a mail client installed on your mobile phone, right? Or you could be using a browser to access email. I go to gmail.com on my browser, or like I open the Gmail app on my phone. It doesn't care what it's talking to. It just has an endpoint and it communicates with that. That's all it does. So it's completely transparent.
Yeah, so there is very thin line between platform as a service and software as a service. Okay, so I think on chat a few colleagues also mentioned Gmail or Office 365 as a SaaS-based solution, and I replied to them that it is more as a platform as a service.
Okay.
So yeah, I think the main my understanding might be a little different. Means I think the definition of more SaaS and PaaS is basically when customers try to access the application. Means different customers try to access the same application, then it would be more as a SaaS-based application. And in case of platform as a service, for each customer, they might have their own identity to log in. For example, I create an organization, okay, and for that organization, all the resources, for example, Sagar and everyone, when they log in, they will land up in their own organization. For example, I can go to Gmail and I say that, okay, create a corporate account for Glisten. Okay, so all the services that Gmail, for example, Google Docs, then Google Chat, then there are Google Drive. So all those functionalities are already provided as part of the Google app that I purchase, account that I purchased for my employees. Okay, so then they create a sort of partitioning of that data that, okay, Sagar, this is a Gmail platform. So whenever you purchase a Gmail platform, you will get all these functionalities. Okay. In case of SaaS, it is basically there is no grouping of users, I would say. Okay, so it is a sort of, okay, when I log in, it could be a sort of more as a independent kind of thing. Okay, rather than a grouping. For example, when I log in using Sagar at Glistensoft, I might land up. I can customize the interface and I can use it only the services that I need. Okay, and Vinu might log in with his other MyCarIQ account, and he might be able to customize the application based on his requirement. So there is a very thin line, I would say. In some cases, it would merge with each other because the PaaS email kind of is a very wide domain, I would say, where people have tried to optimize around it, and they have converted their PaaS into a SaaS-based provisioning as well. Okay, so that is where there is why email where we got a disconnect kind of thing. CRM is a SaaS-based, proper SaaS-based thing that I would say. Yeah,
Yeah.
Vinu,
Okay.
you can go.
So, yes, as Sagar said, there is a very thin line differentiating. So the school of thought which I kind of follow, and this I'll kind of give you examples to explain it, right? So let's say the way CarIQ started off, the application servers, everything run on infrastructure as a service, right? And I decide I don't want to take on the headache of managing a database, right? Because if I have to configure my database server, I probably need to configure replication and things like that. So it kind of becomes a hassle for me. So I say like, okay, Azure offers a database as a service, which is basically a platform as a service, right? I say provision 5 GB of storage, 10 GB of storage, 10 TB of storage, whatever. And I say, create a database for me. And now whatever application I've deployed on infrastructure talks to this database, which it's using as a platform, and it works, right? Now I can go ahead and take this further and completely abstract it for the end customer. What CarIQ does is it offers services to what do you call enterprises. It works with insurance companies, right? Now, what I do for an insurance company is I package the whole thing together and I make a deployment configuration where in the backend it deploys whatever the VMs, the database server, or it could be a single database server with multiple databases catering to insurance company A, one catering to insurance company B, and everything. So it's completely transparent to them. What they do is they are using the CarIQ service, the software, right? At that point, the whole CarIQ offering is a software as a service. What CarIQ is doing internally is using VMs as infrastructure as a service to run the applications and using database as a platform as a service to host the database, right? So in a single scenario, we are covering software as a service, platform as a service, and infrastructure as a service. So it depends on the perspective. Right, Sagar? You're mute. I'm assuming. Yes.
Yeah, that's right. Yeah.
Yeah. Right. Okay. Now, after virtualization, another new technology wave came up, which is basically containerization, right? Virtual machines are kind of relatively heavy because you have to deploy a complete operating system. You have dedicated storage, dedicated RAM to it. You know, the OS image takes a lot of space and things like that. So on a single physical machine, you know, you could run probably, let's say 10 VMs because each VM is configured with, let's say 2 GB of RAM, and because the OS overhead is significant, right? And the physical machine allows you to run, let's say it comes with 32 GB of RAM. The hypervisor and overhead and whatever takes 5-6 GB. So effectively you have about 24 GB available, and at 2 GB each, you could probably run only 12 VMs in it. So what containers did was they said like, let's make things leaner and meaner, right? You have the base operating system. You have a container running on top of it. Containers are extremely lightweight. You know, it's effectively just using the memory required for the application and the libraries. So now suddenly you could have something which is as low as, let's say, 64 MB, 32 MB, or like, you know, if it's something slightly more significant, you would devote a GB to it or something, but you don't have the OS overhead inside the container. Now, suddenly what's happening is inside a physical infrastructure, you could potentially run hundreds or thousands of containers instead of just running 12 VMs as we talked about earlier. The other advantage of containers is that containers can be packaged and made distributable. So because they are lightweight, they're small in size, an image could be just like a few MBs. You use something like an Alpine Linux distribution, it's like just 2 MB or something, a compressed image, right? It is very easy for someone to download a pre-configured image where, let's say I take an Alpine Linux image and I say I want to deploy a monitoring software like Sensu on it. I create a container. Now that 2 MB becomes something like 70 MB or something. That's about it. If I take a bare minimum VM, it's going to be a couple of GB. Then I install Sensu on it and whatever, things become really big over there. So this is one of the advantage of containers. Now, how does containers play into the whole, cloud platform? They came up with the concept of something known as serverless, right? So you see the evolution from left to right. You had physical machines, then virtualization came up, you had virtual machines, then people came up with containers, so you had containers, and finally cloud guys said, let's come up with serverless. What does it basically do? Physical machines, I had to maintain the servers, right? Then I said the server is the headache of the data center guy or the hosting provider. I'll run virtual machines on it. You take care of the physical infrastructure, right? Then the cloud guy said, okay, forget about taking care of your virtual machines. We run the physical hardware. We run the container software on it. You deploy your containers on it. You just take care of your containers. That's all you do, right? Then, but you had to still kind of manage your containerization layer. With serverless, what they said is, forget that also. We take care of the containerization layer for you. We have a massive set of servers available where you can run your containers. You kind of have pre-configured options, like let's say you want a container with Java, with Python, with Node.js, with Ruby, whatever, with Go. You decide that. You get a container, you just write a single function to perform a specific task and you deploy it as a serverless function onto those containers. Those containers are no longer your headache. When your client application invokes that function, right, the cloud service provider decides that I have an instance of that container running or that function running. I don't have it. I will spin up a function. I'll make it available for you. You can run it. You get your data in return. And depending on the policies you have defined, I shall either terminate that function or keep it alive to receive any further requests. If it's idle for a certain time, I will terminate the function also. So now with serverless, what basically happens is that you're getting billed on a per call basis, right? Which is great during the initial days, because you wouldn't have too many API calls and whatever, so your OpEx cost is really low. But as you probably start scaling up and reach massive scales, you find it to be a very expensive proposition, right? But then the flip side is during your early days, typically what happens in a startup is you have limited resources available in terms of developers, right? Or people who are managing the infrastructure for you. What do you want them to do? Do you want them to focus on the business logic so that they can quickly develop the application and deploy it? Or do you want them to focus more on managing the infrastructure? So serverless is brilliant at that point. You don't have to do anything. The developers sit down, write the function. The application invokes that function. It talks to a database, gets the data, gives it back. That's what it does, right? But in the long run, it definitely proves to be more expensive.
So just to add to that, serverless came into the picture because I think it is the same concept of going with a cloud computing. Okay, it is a different level of cloud computing. And to give you an analogy, just like earlier we gave the example of IRCTC or a Flipkart sale, serverless is something similar. Okay. For example, if you want to send an email, okay, a transactional email. For example, when you do a order, place an order, you send an email to the, okay. So to send an email, why do you need an email server to be running continuously? Rather, it is just a fraction of a second kind of operation. So I can just use a service where I get a transactional operation. For example, the Python example that you gave. Okay, so you want to do some operation. It is going to take a sort of say fraction of a second to do the processing. Or say you want to do the addition of say 100 numbers. Okay, in computer it would take less than a second. Okay, so would you be running a physical server or a VM for say couple of hours to do the processing? The answer could be no. You can just write a function, pass it on to the serverless service. It will do the compute for you and it will return the result for you. So that is where you are saving on the operational cost again. For example, I don't need because to spawn a server or configure a server and then do the operation, you are spending significant amount of resources to do that. Even if it is a cloud-based environment, you will still need to spend 5 minutes to launch a VM, then do the operation, configure it, do the operation. After the operation is done, again destroy it. So you might spend up almost half an hour to do that operation. With the serverless, you can do it in less than a second, kind of thing. So that is where you are trying to optimize, applying the same concept at a different level. Uh, Serverless is about.
Thanks, Sagar.
Kevin, yeah.
Right. So the other thing, what you hear about cloud, you hear the terms private, hybrid, public cloud. This Venn diagram is very descriptive, but I would appreciate it if someone can tell me what private, public, and hybrid clouds are.
I think we know you will need to do the honors.
Okay, fine. This might be slightly blurry. Okay, so I'll just read it out for you. Right. Public cloud is basically something which is offered by third-party providers. What is a public cloud? AWS, Azure, Google, GCP. These are what do you call public cloud instances, right? Anyone can go and subscribe to it. You access it over your internet. They provide all the cloud functionality of scaling up, manageability, and everything. That's what they provide, right? What is a private cloud in contrast to that? A private cloud is something which an organization runs inside its own data center, let's say. Let's say it's a bank or a financial institute. They could have a very sensitive data. So they'll say like, I don't want to run it on a public infrastructure because either they are paranoid or the government regulations mandate that it cannot be on a public cloud. It has to be on your own infrastructure, right? So then if you don't have a cloud setup, you're going back to your old school data center, the inefficiencies of physical infrastructure, each department having its own thing and things like that. So versus that, what you do is you deploy your own private cloud. So the organization pools its resources together in the data center and deploys what do you call a cloud service on top of it. And various departments utilize those resources. The cloud platform which you have deployed would give you exactly the same functionality what you're talking about when you talk about public cloud. So a department could go and say like, hey, I need to spin up VMs, or like, hey, this is on this what do you call container cluster, go and deploy this container and run the service over there and things like that, right? Uh, with a financial institute also, is all the data very secretive and to be maintained in your own private cloud? Not necessarily, right? End of the day, a private cloud is still more expensive than public cloud purely because of scale of operation. Look, a bank could have like 100 servers, 1,000 servers. That's about it, right? When you go to AWS, you're talking of hundreds of thousands of servers, right? So the efficiency of scale is at a different level for a public cloud. For a private cloud, it's at a different level, right? So why not try and marry both the public cloud and a private cloud and come up with a hybrid cloud? So you leave all your secure data in your private cloud. Whatever can be moved out, you move it to a public cloud. You set up a communication channel between your public and private cloud, and you let things operate, right? I gave you examples of public cloud like AWS, Azure, GCP. Examples of private cloud is you could go ahead and deploy your own OpenStack instance. You could use a proprietary product like from VMware. You deploy their software-defined network, NSX. You deploy vCenter for automation. You deploy vRealize, things like that. That's how you deploy your private cloud. And you have ways to integrate that with the public cloud like AWS. So that's what a public, private, and hybrid cloud means. This is like cloud from a very generic perspective. Now, if we go to the market leader, which is AWS. AWS controls over 30% of the cloud market. Azure comes second at about 20%. And the third largest player is GCP, which is probably about 6-7%, right? So you have one option, you pick up your skills on AWS because there is sufficient demand. You could pick up skills on a smaller player because demand is not great, but combined with it, the available technical resources are also lower. So, you'll probably get paid better over there. It's your call. I'm just covering the biggest player in the market, which is AWS. If you go to AWS site and click on products, you'll see a massive list of products. This is just kind of a sub list of their products. Like, they have services related to compute, storage, database, migration, blah, blah. It's a huge list. At the bare minimum, right? I would say the ones which are marked with a star, you need to explore those. You need to be aware of compute, storage, networking, and how do you manage to work with AWS. At a bare minimum, you need to know this. But again, within each of these sections, they have multiple options available. You don't need to know everything, right? What I've done is I've gone ahead and listed out some of these services over there, right? And it's in the, descending order of importance, right? I'd say go ahead and learn EC2, Elastic Cloud Compute, which is basically the VMs first, right? How do you auto scale the VMs and all? Then if you want, you can start learning about their containerization services, ECS. You want Kubernetes, you can learn Kubernetes. We move to serverless, you start learning Lambda. It always helps to start with the most basic one, which is EC2, right? For storage, if you start with an EC2, it has an attached elastic block storage. You need to understand it. You have different types of storage. You need to understand those. You start working with that. But it's kind of like a finite storage. Simple storage services like a blob storage, it is massively scalable. You don't have to worry about it. It's really cheap. You start working with that. And in case you want dedicated network storage like an NFS or something, AWS provides something known as Elastic File System, right? The basics of networking is like you create your own private network, which is called a virtual private cloud. You define a network, you define the subnets, you define you deploy it across multiple availability zones. You define it as this is my private net, this is my public net, this is my database net. You define all that over there. You will need to work with load balancers to ensure highly available or highly scalable applications can be deployed over there. Now, what users typically end up doing is their what do you call way of interacting with AWS is purely through the web console. It's great. It's a very nice interface. It's user friendly and everything. Great, but a web console is point and click. You will not be able to automate tasks. I would suggest that get familiar with the AWS CLI, command line interface, right? It's a Python based command line interface. You can use that, pass credentials to it, pass parameters to it, speak to different services, get the output. You get the output as a JSON file. You can pass the output and in the script decide what the next step of action could be. You can automate a lot of things over here. So this is basically what cloud and AWS is about, right? We are open for any additional questions you guys have.
I think one on the group, we know one of the questions was about private cloud examples. Okay, people would like to understand some of the examples of private cloud. So one of the typical example where the private cloud will kick in is basically banks where they don't want to push their sensitive information on the public cloud. Usually the public cloud, there is a lot of hesitancy in terms of security. The main reason why people are still not open because of the benefits that cloud computing provides. People are still hesitant to go into the cloud is mainly because of I think security has been one of the major blockers. Right, there is issue with adaptability of the technology. Okay, and so when you go into the enterprises, is another example. Most of the enterprises have done a lot of investment to procure the infrastructure, and if they move to the cloud, then their huge amount of infrastructure they had done years earlier will not get utilized. Okay, so what they have started doing is basically convert their existing infrastructure into a cloud-based private cloud. Okay, so for cloud computing, you do not need a very heavy server. Okay, you do not need a server with 100 GB of RAM and say terabytes of storage, nothing like that. Basically, any commodity hardware can be converted into a private cloud. Okay, there is no mandate or prerequisite requirement. So big players like telecom companies where to provide the functionalities, what they had done was basically they had procured a lot of physical servers to provision the services that they were offering. And considering the shift to most of the companies are now requesting for a cloud-based solution, microservices architecture, and that is where they said that okay, let's try to convert our physical infrastructure that we have into a cloud-based thing. So what they have done is they have converted their services or applications into a microservices architecture, which can be deployed on public or private cloud both. Okay, but yeah, they are internally using private cloud. Telecom companies is one example. There could be many more examples, like say in the pharma domain. In the pharma domain also, there might be companies who had done a lot of infrastructure procurement, and in such a situation, what they will do is basically rather than allocating procuring new servers or move to the cloud and dump their physical servers, what they would say that okay, for my XYZ department, I can start using it or sharing the resources. That one of the diagrams that Vinu had shared, that I have two departments. Okay, and one department has server one, second department has server two, and they are not utilized at the fullest capacity. So what they have done is they have put together a sort of a private cloud, and then they are sharing the resources across within the organization. Okay, so this is a typical example of a private cloud where they have tried to capitalize on the resources available with them to convert it into a private cloud. Okay, so there might be many more instances of private cloud. Okay, and when we talk about cloud, it is more of a concept rather than the implementation. Okay, so for example, take an example of CDAC. CDAC might have say a few servers across different. They might have different. Uh, uh, Suppose Akurdi is one center, and then other center might be. I think on Model Colony is one another center. Then there might be a center in Nashik. So instead of using each of the centers as their infrastructure, having their own dedicated infrastructure, they can be combined into a single cloud-based implementation, private cloud, and each of the departments might be able to share the resources. So using cloud computing, you can create different accounts for different teams, and you can capitalize on the same infrastructure to serve more users or more students on that. Okay, because all the students might not be using at the same time, so they might be able to provision it for more users. Okay, so there could be a lot of combination of examples around the private cloud. And hybrid cloud example is typically a bank which might say that, okay, I don't want, or organization where I don't want to share my passwords over or database over the internet. I will keep it in my private network. But the application that I have, which can go over the internet, so the application might be hosted over the internet, and there might be a dedicated connection between the cloud-based application and the database in the private network. So there could be some combination of such applications which can still capitalize or take the scalability or auto scaling features of cloud computing, and use the security of the private network to get a sort of hybrid model where both the uh, requirements can be justified to achieve the goal.
So another scenario for a hybrid this is a company could be in a state of transition, right? They've already invested in hardware, right? And they know that over the next 2 years or 3 years, all this hardware is going to be redundant. I'll have to invest in new hardware, right? Because it's outdated. So do I incur a capex to buy new hardware, or do I move to an OpEx model where I can start using a public cloud? So what they do is they deploy a private cloud on their existing hardware, and they work on their applications, as Sagar said, convert it to microservices or whatever, make it suitable for the cloud, and they start migrating it over a period of 2 years, right? So by the end of 2 years, what basically happens is that you can scrap your existing hardware in your private cloud. You can stop your private cloud completely, and you are on the public cloud now, right? So that interim 2-year period is where you're using a hybrid cloud, where you're transitioning from private cloud to public cloud.
We know other question is about scalability and elasticity in cloud computing. What's the difference between them?
These are
yeah. You want to take it up, or you want me to respond to that?
Go ahead.
Okay. Yeah. So scaling and elasticity is, I think it is more of a conceptual difference. Okay. So you can go into scaling of the servers if you have a elasticity. Means, for example, you can, if there is a demand, okay, you can add more servers if you have a compute capacity in the background. Okay, the example of Flipkart sale is basically, we can take an example to discuss over here. Okay, so you would be able to scale for that sale period because your infrastructure is elastic. By elastic, you mean that, okay, see, elasticity, you can take an example of a rubber. Okay, you can pull a rubber till its breakable breakpoint is reached. Okay, you cannot scale it up. If you have a physical compute power available to you for creating 100 VMs, then you can, it is currently you might be running only 10 VMs. Okay, you can scale it up to up to the 100 VMs. Okay, so that is your elasticity, that you can pull or you can launch more VMs till you reach that 100 VM capacity level. Beyond that, if you try to fill in, push it further, it will break, kind of thing. Okay, so elasticity is just a capability to scale. Scale is basically launching of the new compute. Okay, so it is more of a execution. Elasticity is just a capability. Okay, so you can have a auto scaling capability to scale up to the elasticity reach or point of elasticity. How much you can pull your infrastructure. Okay, if you don't have a compute in the bottom line, physical infrastructure compute scaling capacity is exhausted, then you won't be able to scale beyond that. Hope I was able to express it because it is very different, I would say.
I know it's kind of a very what do you say, academic definition or whatever. The argument over elasticity and scalability. In the real world, just go ahead and use it interchangeably is how I look at it. You know, it really doesn't matter much. Yeah.
Yeah.
Yeah, from an academic this, if you have a question coming up in CDAC, you better give Sagar's answer.
Yeah, we know. I think we have just 45 minutes for the session. So yeah.
So can I just take a small break and just come back before we start the next presentation? Yeah, give me 2 minutes.
While Vinu is taking a break, if there are some more questions, then feel free to post it. Okay, I will try to respond.
Yeah. Participants, Mr. Vinu will be back, so don't go, because the other part of it is yet to be covered, DevOps, that will be covered. In the meanwhile, Mr. Sagar is there. So any further doubts or any further information you want to seek, feel free to put it in the chat.
Right, so the first session was more related to cloud computing. It was kind of preparing a base because DevOps became more popular once cloud computing came into the industry. I think AWS has a very high market share in the industry because I think AWS came up with the concept way back in the year 2007, I believe. Okay, so they had already started providing the services in cloud domain. And if you look at the history of it, I think they started with internal provisioning of the infrastructure and trying to automate things around that, and eventually later they started offering services to the customers way back in 2007. Okay, and there at that time cloud computing was not very much popular. Whatever the challenges you see right now, I think it has been evolved or accepted more in the industry is basically because the way of operations in the industry has changed. In the initial phases, customers used to, there were not a lot of startups. Okay, so that is where a lot of enterprises were ruling the market. And that is where the cloud computing didn't click because they had already procured a lot of infrastructure. And eventually when startups companies came around, they didn't had the bandwidth to allocate a operations engineer or someone who can do the infrastructure and configuration for them. So they started going to the cloud-based thing, though it might cost them a little additional. But yeah, rather than doing upfront cost investment to procure the servers, they felt it ideal for going to the cloud and getting the infrastructure on demand. So that is where the concept of cloud computing kicked in, and it became more and more popular recently.
So yeah, I mean, to add to that, the term to describe it is basically cloud computing lowers the barrier to entry, right? So as Sagar said, it lowers the barrier to entry for startups. A startup might not have the required capital to buy physical hardware, and or possibly even scale up the operations. So you're on the cloud, your capex is off, you're running it on opex. It becomes easy. For an established company, also, a cloud makes sense. Let's say a department within an organization is looking at a new product and they want to test it out. In the traditional model, what they'll have to do is they'll have to buy their own hardware. So it goes through their internal process. It'll take a few months. The hardware gets provisioned. They'll test it out, and only to figure out that this product has no market at all. It's not going to work. So it's a waste of your capital expenses. Versus that, what they do is they say quickly, like, let's test out the app, let's go to the cloud, let's deploy it, test it out. So now suddenly your barrier to entry is non-existent. It becomes way, way easier.
Yeah, other example we can use of CDAC only. Maybe CDAC might already have their own private cloud, but if you talk about 10 years earlier, then in case if CDAC had to arrange for a sort of a lab for the students, then they might have to plan it a couple of months earlier, because they need to work out on with different vendors, get a cost estimate on how much it is going to cost, create a budget out of it, get the budget approved, and then raise a PO with the vendor to do the procurement. And maybe after a month or so, the vendor will deliver the servers or infrastructure, computers for the students to work on. And then there would be a network configurations, setting up the servers, etc. So it could have been a 3 to 6 months kind of project in all. Okay. And these days, if you say, okay, AWS provides a service that, okay, all the CDAC students can use AWS for around, say, 5,000 or 10,000 rupees of services, they will get it free. Then CDAC can offer it to their students for lab environment within a couple of minutes, kind of thing. So that could be a game changer difference of going to the market, or provisioning of the lab environment in short time is what we are referring to.
Right. We are kind of running slow, late. So let's start off with DevOps, right? So my first question is, let's not get into what the meaning of DevOps is. What does DevOps mean? Can someone guess what is the origin of the word DevOps? How do you come up with a word like DevOps? Someone raised the hand. Can you just type it out on chat?
I think I got 2-3 answers on the chat. DevOps is a set of practices that combine software development and IT operations, which is correct. Development team and operations team. It is a culture or practices and combination of development plus operations. Integration of development teams and operations team.
Right. So that saves me the effort of the next 2 slides. I'll just quickly cover it. Basically, you have who's a developer, right? a developer is someone who does R&D, does the programming, maybe even the QA testing guy falls under a developer. They come up with an application or a software. These are the guys. The other end is IT operations, as you all said correctly. This is basically the team which ensures that the infrastructure remains functioning. They take care of deploying the software into that infrastructure. They manage it. That's what they take care of, right? So DevOps is basically a combination of developer and IT operations combined together. It's DevOps, right? Now, how do you really do it? As you said, yes, it's software development and delivery process. It's a combination of that. What you do is you're trying to automate everything over here, and you make it a quick process through automation. You make it reliable, you make it repeatable, right? And more importantly, what do you say? It is a continuous process. It's kind of like an infinite loop. If you look at the next slide, right? It is an infinite loop. So this is like a very generic description of DevOps. What you do is you start off with your planning phase where you decide, hey, this is the software I want to develop. These are the features it needs to have. I document it somewhere. Then the developers go and they start coding on it. They build an application, right? You kind of build the application after coding it, and you kind of test it, deploy it, right? And the operations team at that point manages it and sees it. In case there is a bug, the end user reports a bug. The operations team says, gives a feedback back to the developers and lists out like, this is the bug with the software. So the development team kind of looks at it and says, hey, let's fix it. They write the code again, you build it again, you go through the loop again. So this is a very generic infinite loop of DevOps. It's very rapid, and it's rapid because you have real-time communication between the various stages. This is a very generic example. A better example to show is the solution from Atlassian. Atlassian is probably the market leader when it comes to offering solutions for this, right? You look at the various solutions they offer as a part of it, right? You have Jira software, which is basically an issue tracker. You have Confluence, which is like a what do you call, knowledge base, right? So a product manager comes up with the requirements, puts it up on Confluence. A project manager looks at the product manager's role and says, like, okay, fine, this is how we need to go ahead and plan our development process. So he goes on to Jira, creates, sprints, defines tasks and everything, and comes on it. And puts up a work list over there. What the developer does is he goes, picks up a ticket from Jira and starts working on a functionality, right? He writes code, he commits it into a source code control system, which is Bitbucket over here, right? And during this whole process, the communication is happening real time using their chat software called HipChat. This is all tightly integrated. Now, what you do is you take the code from Bitbucket, and Atlassian has a service called Bamboo, which does testing, building, and deployment, everything, right? So you move through continuous testing and deploy, and then the operations guy are using service desk, right? Any issues which happen with the production deployed software or whatever, it comes to them. These guys look at the ticket, they document bugs into, let's say, Confluence, or probably like, they will go ahead and create a new ticket which is required in Jira, saying that this bug needs to be fixed. It goes back to the project manager who says, hey, this is an important bug which needs to be fixed right away. This is something which can wait till the next product release. So let's look at it, 2 months later. And it goes to the software developers, who repeat the process of fixing the bug, or coming up with a new feature. And this loop continues again and again. This is the Atlassian world.
We know there is a question: which methodology followed in DevOps?
I am not too sure if I understand the
Right.
question.
So let me maybe I could be there might be it is the question seems quite generic in nature. There could be multiple answers, but my interpretation I will try to answer it. Okay. So just a quick question that okay, why do you think DevOps has become popular these days? Any guesses from the audience? Well, my answer would be I don't see any response yet, but my understanding is basically people are shifting the development cycles to a agile methodology, which I think you might be aware of the concept. Uh, in the traditional way, if people had a waterfall model of implementation, a release cycle typically used to take 6 months. Okay, and to do that application deployment, you might usually do it maybe once in 6 months. So ideally, you might be spending a day of deployment efforts. So there was not a lot of automation thing that was kind of a sort of pressing need of it. Okay, and with the agile methodology that came in, people are talking about 15-day sprints. Okay, so within 15 days, you have to do a development cycle, you have to do a testing cycle, and then in that case, deployment cycle was also accordingly fast. Okay, and in that case, usually you need to do a repetitive operation. For example, testing. Every 15 days, you have to run the same testing again and again. Earlier in the waterfall model, you used to spend almost 4 months of development, 2 months of testing, and 1 day of deployment. So it is kind of manageable kind of operations. Okay, with the sprint based approach, the work of overload has increased, repetitive task has increased. Okay, so whenever there is a repetitive task, you look at try to optimize or automate it. Okay, and that is where the DevOps came into existence, that wherever there is a repetitive operation that you want to automate it, you will try to reduce your workload. Okay, and that is why the it is a sort of continuous improvement loop that we are talking about, because you learn from okay, this functionality I am doing it repeatedly, so let me try to optimize it. Okay, for example, every testing cycle you will do the same regression testing every 15 days. Okay, because your release cycle is every 15 days now. Okay, so rather than testing manually testing it, let me try to automate it. Okay, I am doing the same deployment every 15 days. So rather than doing it manually, let me try to automate it. Okay, there might be some configuration changes during deployment which you are trying to do it again and again every 15 days. So let me try to automate that operations frequently. Okay, so there can be, if you look at this cycle, Ansible, it is okay, new server, I am trying to add it. Okay, so when we are talking about, if you look at the offers that Flipkart example, let's go back to that. So Flipkart is coming up with sales every frequently. Earlier, you used to get it only during Diwali, the offer. Now it is more frequently. Okay, there is Ganesh Chaturthi, come up with a festive offer. If there is a 15th of August sale, then there is a Christmas sale, then there is a 26th January, then Holi sale. So people have started coming up with more offerings. So you need that repetitive task that okay, whenever there is a sale, now it has gone to a hourly sale. On Amazon, if you go, they will say that okay, offer of mobile phone is available only at 12 p.m. to 1 p.m. Okay, and within that time period, also within a second, the mobiles are sold out. Okay, so people are going with an advanced way of release cycle. So in that case, you will need to provision new servers at runtime. Okay, whenever you want to provision a new server, the configuration, etc., you will need something like a Puppet, Chef, or Ansible kind of tools, which through which you can do a provision. And then the application release, when you want to do it faster, you might want some sort of a Jira or different automation like Jenkins or Bamboo kind of automation, provisioning, build tools, etc. you will need for frequent kind of operations. And then the entire cycle gets built over there. So I think if you look at it, is more of a concept the kind of thing that you are trying to automate, and the root cause of it is basically the way in which we operate has changed. Earlier it was a waterfall model where you used to take couple of months to do a release. Now you are talking about 15 days, and some of the things are more dynamic where you do it on a weekly basis also.
Yeah, so just to add to that, even 15 days in a week is a very long time. If you look it up, the big companies like Amazon and whatever, Netflix and all, they have probably hundreds of thousands of releases every day, because everything is microservices, a small component gets updated. So you could have like an update happening like every hour, every few minutes. You really don't know. And then the other thing about automation, what Sagar mentioned, right? Automation kind of provides one big advantage in the sense that, of course, you're kind of not doing repetitive, boring tasks. It becomes repeatable easily using code. But more importantly, anything which involves a manual process is prone to errors, right? Now you have a repeatable automated task. You run it the first time, you run it the second time, you know the behavior is going to be exactly the same because there is no scope for manual error to creep in, right? So automation has a huge advantage over here. So now going ahead, moving from the Atlassian world to let's say an open source or like third-party world. This loop is kind of broken down into smaller segments, right? So for planning, I think Jira is still the most popular over there. GitHub and all have their own this, but I keep hearing Jira most of the time everywhere, right? For coding, you use Git, you can use Subversion. Again, Git is by and large the most popular one. You use IDEs like Eclipse, which is integrated, everything. You have build systems like from the Java world, which is Ant, Maven, Gradle, NPM from the Node.js world. You use these things to build. For testing, you use Selenium, JUnit, you have SonarQube, things like that. Jenkins leverages Maven, Gradle, and whatever, to build the application and release it and deploy it, as does Bamboo, right? Now, once you have deployed it, we are talking about configuration management, which is taken care of by Ansible, Chef, Puppet, SaltStack. My personal preference is Ansible. I find it extremely simple to use. It's a wonderful tool, right? Now, as you're running it, you need to monitor it. You can use open source tools like Sensu. Splunk is an expensive proposition, right? Then you have the old school Nagios. You monitor it, you aggregate the logs, you use Elasticsearch, Logstash combined with it. You parse the logs, you find any issues, you go back into your planning phase, you create bugs, and this loop continues. This is a slightly more broken down version or detailed version of what we saw earlier, right? We keep hearing terms like continuous integration, continuous delivery, continuous deployment. It's kind of confusing. It's, what do you say, an highly opinionated thing, right? So don't be surprised if you ask a question and Sagar gives you a different answer and my answers are different, right? Continuous integration is basically You use Git, every developer kind of creates his own branch. You kind of integrate everything back to the main branch periodically. So, things don't diverge too much. If you don't do it often enough, things can break because the code base diverges too much, so much that it becomes difficult to integrate it back. So what you do is you do builds, unit tests, you do it very frequently. You integrate it back into the main branch of yours, right? That's continuous integration. Continuous delivery and deployment is basically just a process where from the main branch you build, test, and release. Uh, so you're deploying incremental updates as we talked about earlier. The only difference between continuous delivery and deployment is people say continuous delivery is a manual process, continuous deployment is an automated deployment. You can avoid this whole confusion by just using the term CD instead of continuous delivery versus continuous deployment. That's how I see it. Right. Now, if you look at this graph, it kind of breaks it down for you, right? In your dev environment, you have multiple branches. You build it, you run tests on it, you merge it, you build your main branch, and then you put it in your test environment, you run your functional tests, performance tests, everything. The testing process continues. And then finally, you move it to your staging environment where it goes to acceptance test. Once it passes that, it goes into your production environment where you get into the process of continuous monitoring using the tools which we talked about, like, Sensu, Nagios, Logstash, Kibana, Elasticsearch. You use that combination and you monitor this. This is how it works. I'm not too sure how clearly this is going to be visible on your screens. It's just a funky looking, what do you call, equivalent of a periodic table of DevOps tools. If you search for Xebia Labs, XEBIA Labs, and DevOps tools, you'll land up on this page. You'll become aware of the various tools which are available, and like a periodic table, they are grouped into different what do you call, groups. If you want to simplify it, like, these are kind of a list of essential DevOps skills you will need to succeed. You really don't have a choice. Starting from the top at 12 o'clock, the operating system of choice, Linux. Linux dominates the whole landscape. Even on Azure, Linux is its biggest deployment. People don't use Windows on Microsoft Azure. I mean, they do use it, but Linux is more common than Microsoft Windows. So knowing Linux kind of becomes a primary skill set over there. On the cloud, as I said, you can pick up one of them. If you want to play safe, you go with AWS. Azure is somewhere midway. GCP is kind of a stagnant third player, right? While what do you say, picking up skills on the cloud, I would recommend that you don't need to understand the nitty-gritty of the alternate cloud platforms, but it is always very useful to be aware of what the equivalent to what is there on AWS, what is its equivalent service in Microsoft Azure. So for instance, what we call serverless as Lambda in AWS is called functions in Microsoft Azure. End of the day, both of them are serverless. The functioning, the logic behind it is going to be pretty much the same, right? You just need to figure out how you go ahead and do it, right? Monitoring, Sensu, Prometheus, really big. Nagios, a wider install base, right? Scripting, Shell, you cannot kill Shell. Bash is still going to be around probably for another 20 years. I don't know, pretty much forever. Python's a very flexible. Go is catching up. Ruby is there, so you can work on those. The miscellaneous ones which you're talking about, yes, definitely pick up Bash, not Bash, Git, right? Uh, when you start working with on DevOps, you are going to write code which you will leverage to automate and repeat stuff. It makes sense to have it in a version control system. So Git is my choice. It's way ahead of other version control systems like Subversion or CVS. So Git could be like you use it on Bitbucket, you use it on GitLabs. It doesn't matter. The underlying system is Git, right? Pick up a very flexible text editor of your choice, Vim, Emacs, whatever. It's your choice. Pick up skills with useful utilities like sed and awk, figure out how to parse JSON using JQ. These are all very useful skills to have. On the other side, you have CI/CD, Jenkins, the leader, Travis, not so big, Bamboo, proprietary product. So I'd say go with Jenkins. For automation, you have Ansible, Puppet, Terraform. I'll come back to Ansible and Terraform in a bit, right? Containerization, it's basically just one technology, which is Docker right now, which is like way ahead and the absolute market leader. The container orchestration market is kind of fragmented. The big player over there is Kubernetes. You could use Nomad also, which is from HashiCorp, or you
We
could.
know while you are there on Docker and Kubernetes, there is a question that can you tell difference between Docker and Kubernetes?
Okay. Sagar, I'll let you take that because you're way more comfortable with these than I.
Right. Yeah. So Kubernetes is mainly a orchestration, or when you talk about orchestration, it is more of a resource management. Okay. For example, if you have a 10 node Kubernetes cluster, and when you start a service, what happens with that service, on which server it will get launched. So that management of the resources is taken care of by Kubernetes. Okay. Docker is more of a service, you can say. Okay. Or more than a service might have multiple containers. Okay. So Docker is basically a container, you can call it in simple terms. Okay, and Kubernetes is a sort of manager, you can say. Okay, it is just like you are a student, and basically CDAC, you can call it as a Kubernetes who is trying to shape up you. Okay, and you might end up into different fields and technologies in the IT world. Okay, so it could be a bad example, but I'm just trying to correlate it. Okay, and just trying to make things simpler for you to understand. Okay, so Kubernetes is more of a resource manager where it manages where the service containers will get launched. Okay, so for example, if you need a container requiring 8 GB of capacity, and there are two servers with 4 GB of RAM and one server with 16 GB of RAM, then it will automatically select the server with 16 GB of RAM. Okay, so that resource management is what Kubernetes is. Okay, and if the service crashes or one of the container crashes, then it will get auto restarted and auto configured on the nodes where the resource is available. So that resource management is handled by Kubernetes, and Docker is more of a individual container that runs. Okay, so when you bundle a particular application service into a Docker or microservices architecture, then it would be a leaf node, you can say. Docker is more of a leaf node in the Kubernetes cluster. Also, there is one question related to Git and GitHub difference. Okay, so we know, I think it should be, I think you can take that up. I don't think.
Yeah. So look, Git is basically the technology, right? Which is a version control system. GitHub is just a service which is using Git. Like Bitbucket is using Git to offer the service. Bitbucket also provides you the option to use, let's say, Subversion also if you want. Is that clear?
Yeah, I think that should be good enough, I believe.
Right. So I don't know if this is the right way to describe it. To add to what Sagar said about Docker versus Kubernetes, Docker is basically, I'd look at it as a single host with containers running in it. Kubernetes is a way to manage a cluster of Docker hosts, right? Sagar, would that be a better description?
Yeah. You can use it in multiple ways, right? Yeah. So
That's
you can have a single node Kubernetes cluster as well.
correct.
Okay. Yeah. Conceptually, yes. So within that single host also you can do a resource management using Kubernetes. But yeah, a proper use would be when you go into a distributed architecture. Right.
Right. So coming back to automation, talking about Terraform and Ansible, like, theoretically, both can be used interchangeably, but it's not really the right way to do it, right? Uh, Ansible typically is used for configuration management, and uh, Terraform is used for orchestration. Terraform is used for typically what do you call orchestrating infrastructure, right? So it could be networks, it could be VMs. Terraform is a multi-cloud platform, so it integrates with lots of things. Terraform has a plugin for Ansible, so it can get Ansible tasks done. But I would typically stick to using Terraform for orchestration-related works and Ansible for configuration-related works. Terraform has another advantage. It maintains the state of your existing what do you call infrastructure, and does an incremental update to it, whereas Ansible just knows the desired state and pushes you to the desired state. It doesn't know what the current state is. It doesn't maintain a state at all, right? Now, this is like the open source world. Okay, so another point of interest over here is like Terraform, Nomad. I haven't mentioned a few other things like Consul, uh, Packer, Vault. These are all products from a lovely company called HashiCorp. They're wonderful tools, all open source. You should check those out. Vagrant, Packer, Terraform, great tools, nice to know tools, right? Now moving from the open source world, if you want to work, let's say in an AWS universe, what is the equivalent? These are the set of products you would end up using from AWS, right? So they have multiple products for CI/CD, for infrastructure as a code. Instead of what do you call Terraform, you end up using CloudFormation. The disadvantage of CloudFormation is it's very AWS specific. It works only with AWS. With Terraform, it has plugins for AWS, Azure, Google. So you could use Terraform and work with different clouds, hybrid clouds. That's how it works, right? You have OpsWorks, System Manager, config. Monitoring and logging, you would use CloudWatch, CloudTrail. You know, these are things which you'd end up using in advanced debugging and monitoring types. You probably won't need to start with it right away, but you need to be aware of what the tool is, and jump to the tool when you need it, right? AWS offers something called Code Commit, which is basically a private Git instance for you to host your Git repos. So, yeah, this is pretty much what DevOps and cloud computing is about. So, any questions?
I think while the participants are thinking about the questions, one thing I would like to highlight is if you look at the slides, actually in DevOps, Vinu was just dumping more and more tools, technologies, a lot of products that you will need to learn. Okay, so in case if someone is planning to make a career in DevOps, he or she will need to do a lot of technology kind of learning. Okay, because you all these technologies you cannot learn within a single day or 1 week kind of thing. You will need to spend couple of months to get a understanding about the technologies and at least reach to a stage where you can do the implementations, because you cannot do it within a week and say that okay, I'm a DevOps engineer. Okay, means me and Vinu have been working on it since couple of years, and still we feel that okay, we have not reached enough tools and technologies where we can say that okay, we are DevOps experts kind of thing.
Yeah. So, for instance, this is a lovely what do you call visual, which is available on cncf.io. So they have the URL. Just go to l.cncf.io and you'll land up on this a lovely one. What you can do is you can filter it out and say like, just a second. I just want to see the open source ones, right? So the different, what do you call, open source solutions you have, right? So for instance, they've broken it down into application definition and development, databases, streaming messaging, you know. So a lot of it is focused for developers. Some of it is relevant for DevOps, right? So for instance, you have continuous integration delivery, you have Jenkins listed over here, you have GitLab, and
Yeah, so with DevOps, you need to know all of the things, okay, because you are trying to have a operational understanding as well as development understanding. So what developers would know, you might not need to know, as you might not be an expert as a developer, but you need to understand enough of a developer so that you can understand what the application is trying to, how the application is working. And from an operational standpoint, you might not know or you might not be an expert into operations, but you need to know enough where you can try to automate a operational piece. So you need to understand a lot of development as well as operational, means how a Java service, if it is running, or how it needs to be configured, or how to do a JVM tuning of it so that you are able to configure a Java service without any failures. So all those things you might need to understand. If the service is failing, a developer might say that, okay, in your environment it is failing, in my development environment it is working fine. So you need to have that operational mindset to troubleshoot that. Maybe you need to do some fine tuning of the JVM and parameters so that the service runs efficiently in the production environment. Yeah, I think we know we don't have a lot of questions, so I think maybe.
Yeah.
yep.
Everyone might be feeling hungry. It's almost one, so.
I would like to thank Mr. Vinu and Mr. Sagar. Also like to know our alumni if he wants to say few words before we.
Oh, yes. We forgot about that part. I'm sorry. Thanks for reminding us, Keshav. Yeah.
Yes.
So yeah, I'd like Shivam to kind of talk about his experience. Like, it's going to be more along the lines of like, you learn things in CDAC and then you land up in a job, which is a real world DevOps job, how things are different over there. Shivam?
Yes, thank you. So basically, I have done my CDAC in British. So I am kind of in DevOps environment from the operation point of view. And what CDAC does in 6 months is very best job, and it actually prepares you for the conceptual knowledge. For example, if you take example of load balancer, so load balancer will always be a load balancer, and the concept of the load balancer is balance the processing power for application. And AWS has a service called ELB, and how it operates on AWS and any physical infrastructure is the same. So CDAC does a very great job on that. But in a real world scenario, where you have to manage all the concept and integrate all those concepts inside a single job, and you need to operate around that. So from coming from CDAC to as a DevOps engineer on the operations side, so it's basically what the webinar is from costing perspective and automation perspective. There are some differences from technology to technology, as means some of the clients you need to work on different technologies, and for some there are different. So if either if Sagar sir or Vinu sir asked me to secure some of the host or VMs, and tomorrow I go out and buy, so for example, let's say we have 8 hosts, and tomorrow I go out and buy 8 physical firewalls. So what I'm doing is securing the host, but after the end of the month, I won't be an employee of the month. I will get fired because the cost for 8 physical firewall, uh, even if I have secured the host, but I did not do a cost efficient job there. So these are the terms, these are the methodologies you get to learn in the real world, and simply the automation is what you need to learn a lot, because you don't want to do the repetitive task again and again. So that's it. So CDAC basically does its best job to get you familiar with the concepts, and in the real world you will get to know how those concepts can interact with each other, and how you can use the resources you have to its fullest.
Thanks, Shivam.
Thanks. Yeah. Thanks, Shivam. And on behalf of DYPMS and IACSD, Akurdi and DY Patil Pratishthan, I'd like to thank the resource person, Mr. Sagar and Mr. Vinu, and the colleagues of mine, multiple colleagues and my alumni and my students. Thank you all for participating in this webinar, and I hope that you have gained in knowledge and concepts